The topic is about Domino CMOS logic. We'll be going over the topics related to its basic structure, working, properties, and simple implementation of two-input AND gate. Domino CMOS logic is an integrated version of a dynamic CMOS logic and a static CMOS inverter, as shown here. The main reason that we opt for domino logic is that it eliminates the cascading problem that occurs in the dynamic logic circuit. And the addition of an inverter is that it provides a solution to the dynamic circuits by producing monotonically rising input to the next stage. Now, moving to the basic structure, it consists of four fundamental transistors, that is the pre-charge transistor MP, evaluate transistor MN, and two other transistors that are present in the static CMOS inverter, as shown over here. It consists of a pull-down network with n number of inputs as given as per the requirement, and the internal node X is present before the inverter stage, and finally the output capacitance. The working of domino logic can be generally categorized in two phases, the pre-charge phase and the evaluate phase. In the pre-charge phase, the clock is given as 0. As a result, the MP gets turned on and MN gets turned off. Due to this, the voltage gets charged to VDD through the pre-charge transistor. This, when passed through the inverter, produces a logic 0. When considering the evaluate phase, the clock input provided is 1. As a result, the evaluate transistor gets turned on. Thereby, the internal node X gets discharged through the MN to the ground. Thus, the voltage at X tends to 0 voltage, and the final output produced after passing through the static CMOS inverter is of VDD. Now, the implementation of two-input AND gate is done by just replacing the pull-down network with inputs A and B, and the circuit can be realized using domino logic as shown here. Say, for example, we consider this particular circuit wherein the clock input is given as 1 and the inputs A and B are both 0. Right. Here, the internal node X holds the pre-charge value VDD, and when passed through the inverter, it produces the output as 0. Simple realization of is that the output produced at F is always an inverted version of X, which is quite obvious. And F does not depend on the pre-charge or the evaluate phase. That gives an edge over the dynamic circuits. The main properties of domino logic is that it has better noise immunity, low impedance, and only non-inverting logic can be applied. And the number of transistors required are always n plus 4 as noticed earlier. The main advantage is that it solves the cascading effect that occurs in the dynamic circuits and as well as the monotonicity problem. But the only disadvantage is that it generates a race around condition. So this is the general overview of Domino CMOS logic.